Hello, class. Today I'm going to teach you how to synthetically divide. In the past, in just regular numbers, you've been dividing maybe long division or some fancy way your fifth grade teacher taught you. That being said, this is going to be a new way to divide, and it's used to divide polynomials. Before we start, though, it's really crucial that we start by warming up and defining all of these old terms. So some terms are from just recent and some terms are from elementary school. So you might want to take a moment, pause the video, and write down all of these definitions. All right, now that you've unpaused, I'm real quick going to read over them because it is crucial. So polynomial, we're in the polynomial unit. It's a equation or expression having many terms. A binomial has two terms. A binomial is a type of polynomial that's very specific to two terms. The degree of a polynomial, the degree of a binomial, it comes from the highest power. The dividend is actually an old term. So dividend is in a division problem, and it's what is it being divided into. Factors, so they're mostly binomials. They multiply together to get a polynomial. Example, parenthesis x plus 4 parenthesis. Zeros we've talked about so many times now. Zeros are x-intercepts, solutions, roots. They are opposites of factors. Quotient is in a division problem again, and it's the answer of a division problem. Coefficient is the number next to a variable. Divisor is what is being divided by. And R, we're going to call something R now, and that's going to be a zero of a factor. So a zero, an x-intercept, a root, we're calling it R in the steps of synthetic division. So the biggest thing is you need to know these definitions because I'm using math vocabulary in the steps of synthetic division. So make sure that you have this available and you know what these are. So you're given a problem of division. It's a polynomial divided by a binomial. And in this case, this is what is being divided into. So this is the dividend. This binomial, which also looks like a factor, is what is being divided by. So this is the divisor. And then the answer we're coming up with is going to be called the dividend. So again, just old vocabulary mixed in with new vocabulary. You're going to see all of that when I talk about the steps. So if you're having trouble with understanding what the steps mean, that means you probably need to go back to the top of this page and look at the vocabulary. So we are going to start. Here are the steps to synthetic division of a polynomial. So again, the problem is going to start out. It's going to be given a polynomial. Say, okay, what is this divided by this? So step one. You're going to name the degree of the polynomial and you're going to check its order. So you're going to write literally degree. And to name it, you look at all of the x's and say, what's the highest degree? Oh, the highest power is 3, so the degree is 3. Then you're going to check its order. So you're going to write the word order. And what I mean by checking the order is you start at the highest degree and you go down. So you see how you have x to the third, you have x squared, you have x, and then you have no x. This is a perfect order. Things that are not in perfect order is if the degrees were all mixed up. If x squared was listed first and x cubed was listed last, you want to reorder it. If there is one of the degrees that are missing, so this goes 3, 2, 1, none. Let's say there wasn't this x term here, you want to add a 0 in there so it does go in the right order. So check if it is in the right order. If it's not in the right order, you're going to rewrite it so it is in the correct order. Step 2. Step 2 is lengthy. It's the setup of synthetic division. It's weird, but you're going to get used to it. First, you're going to start by making this little L. So, bam. In that L, in the box, we're going to call it, goes the 0 of the divisor. So the divisor, again, is right here. The 0 of it, this is a factor. What's its 0? So this is x minus 4. Its 0 is 4. So again, opposite. You're going to write the coefficients of the dividend next to the box. So this is why order is so important, because we are now going to list these coefficients next to this box. So 2, negative 13, 26, negative 24. Again, just of the dividend, the signs go with it, and it's just the coefficients. Notice how there's no x's. Then you're going to kind of leave a space and make this equal sign. And you're going to make this cutoff bar, we're going to call it the remainder bar, by the last coefficient. So this is the remainder bar, last coefficient. And then you're going to draw first arrow. So the first arrow you're going to draw right here. Here's the setup. This is the setup every time. Step 3, we're going to bring down the first coefficient. So we are going to follow that arrow going down, and we're going to write 2. Again, I'm bringing down the coefficient. I'm not bringing down the number in the box. Step 4, we're going to multiply that number, so this number right here, by the number in the box, the r. And we're going to write it underneath the next coefficient. So if we follow these motions, it's going to be 2 times 4. We're going to write it right here. So 2 times 4 is 8. We're going to write it right underneath this next coefficient. Now we're going to add down. So we have a negative 13 plus an 8. So that number would be negative and then 5. Then we're going to repeat 4 and 5. So we're going to now multiply negative 5 by 4. Where did I get 4? 4 is the number in the box. I'm going to get a negative 20. I'm going to write it underneath this coefficient. Then I'm going to add down, like step 5 says, 26 minus 20 is 6. I'm going to repeat again. Multiply 6 by 4. 6 times 4 is 24. I'm going to add down, and I get 0 in our remainder box. Remember, this is not a 1. This was part of the setup. Right now, we just have a bunch of numbers. They're all mumbo jumbo. We don't have an answer to this question. So to write the final answer, we are going to use the last line of numbers to be the quotient. Remember, quotient means answer of the division problem. Coefficients. We are going to start at the degree 1 less than the initial degree. So up here, our degree was 3. So that means we're going to write the 2 here, and we're going to write x squared instead. Minus 5x. So we went 2, 1, plus 6. So we're adding those plus signs, those x's in there. This was a negative, so this is a minus. And then this is the remainder, hence why we called it the remainder box. So you do plus 0 over top of the divisor, x minus 4. So 0 was our remainder. Normally we don't write 0. You don't have to write 0, but if this was a number, I want you to know that you write it on top of the divisor. And this is our answer. So when we take this polynomial, divide it by this, we get this. And we did it by synthetic division. So again, here's the steps. You might want to pause the video, make sure you have everything written down, because you will now follow these exact steps multiple times to complete the rest of your problems. There's one thing we also must talk about as well, and that is with this little extra step, step 0, and that's if the divisor has a number next to x. So if you look right here, this is 3x plus 1. If you looked right here, this was x minus 4. No number next to x. Number next to x. So if there's a number next to x, you have to identify the coefficient of that number. So this is 3. And divide every coefficient constant by that number. So watch. This is 3, so now I need to divide everything by 3. And I need to rewrite the problem then. So 3 divided by 3 is just a 1, so then it's x to the fourth minus 5 over 3 x to the third plus 1/3 x squared plus 7 over 3x. There's no zero, or there's no constant, so we want to add 0 in. And we want to divide that by x plus 1/3. So see how now this is rewritten as this because there was a number next to this. Now we're going to do synthetic division. So I'm following the steps from before. I'm putting a box. The number that goes in the box is negative 1/3. See that? I'm using these new coefficients. So 1, negative 5/3, 1/3, 7/3, and 0. Arrow down remainder box. And again, these are just fractions, so we're multiplying and adding and subtracting the fractions. Feel free to use your calculator. It shouldn't be that scary. I bring the 1 down. 1 times a negative 1/3 is a negative 1/3. So negative 5/3 minus 1/3 is negative 6/3. So negative 6/3 reduces to negative 6 divided by 3, which is negative 2. Negative 2 times negative 1/3 is 2/3. 2/3 plus 1/3 is 1. 1 times negative 1/3 is negative 1/3. 7 minus 1/3. Okay, so 7/3 minus 1/3 is 6 over 3, which is 2. 2 times negative 1/3 is negative 2/3. So that's a negative 2/3. We write our final answer. This degree was 4, so we drop it down to thirds, then square, then 1x plus 2, and then we want a plus negative 2/3 over x plus 1/3. Now, this is ugly, so we actually can rewrite this because this is a third and this is a third. So we can do negative 2 over the original divisor of 3x plus 1. So there's our answer. There's our fractions reduced to be pretty again by multiplying 1, 2, 3, all three of these by 3. So when I multiplied this by 3, negative 2, multiply this by 3, 3x, multiply this by 3, 1. And there's my final answer. So be aware, if there's a number next to the x in the divisor, you have to do that. So for 7 and 8, you have to do that. For 1, you have to do that there as well. All right, so that's synthetic division of polynomials.